Hello friends, welcome to Susan and John MathTube. In this video, we are going to learn how to integrate between two curves. Okay, we will start with the question. Evaluate the double integral over the domain R, where the integrand is given by xy dx dy and R is the region bounded by the parabolas y square equal to x and x square is equal to y. Okay, in multiple integrals 1, we learned how to find the limits. In multiple integrals 2, we learned how to evaluate integrals. But in both multiple integrals 1 and 2, the limits were kind of like easy to evaluate because it was associated with the x-axis. So in most of the cases you got the limits like 0 to something. Now let's imagine two curves y equal to f of x and another one y is equal to g of x, something like this. So clearly the limits of y will not start from 0, it will start from the curve which lies below to the curve which is on the top. Okay, in such problems, the first thing to do is you have to find the point or points of intersection. Anyway, these two are well-known curves, they are parabolas. I'll give a short note on this. If you ever see y square, you should remember the parabola will be symmetric about the x-axis. So there are two possibilities because these two parabolas are symmetric about the x-axis. Now you look at the right hand side. If the right hand side is positive, then you have to choose this one which is on the positive side of the x-axis. At the same time, if you see something like -3 or negative, then you have to choose this parabola. Now the logic for x square is equal to y is similar. It will be symmetric about the y-axis and ... Okay, so let's make a rough picture. So y square equal to x looks like this and x square is equal to y looks like this. Okay, now let's find the point of intersection. In your class 9, 10, etc., you may remember if you want the point of intersection, you will solve the equations simultaneously. Same is the story if you have a parabola and a line, or a parabola and let's say a trigonometric function. So basically, if you want to find the point or points of intersection, all you have to do is you have to solve the equations simultaneously, and you can use any method you like. Okay, so the equations are y square is equal to x and x square is equal to y. Now look at this. I'm going to eliminate one variable using the second equation. The second equation tells me the value of y is equal to x square, and I'm going to plug in that value over here. So I'm going to get x square the whole square is equal to x. If you know any other technique, you can use that technique. If you want to eliminate x, you can eliminate x, and those things are completely up to you. The aim is very simple. We have to find the points of intersection. Okay, now look at this. This gives me x power 4 minus x equal to 0. I take x common, so I end up with x into x cube minus 1 equal to 0. That gives me x equal to 0 or x equal to 1. Yeah, now I want to find the value of y. When x equal to 0, y will be equal to 0. So that gives me the first point of intersection 0, 0. When x equal to 1, y is equal to 1 square, that is 1. So that gives me the second point of intersection. Now I'm going to mark like this. I'm going to mark x is equal to 1 and here y is equal to 1. Now I have a clear picture, and let's increase the clarity by writing the equations. So as I mentioned before, the red color parabola is y square is equal to x. Y square because it is symmetric about the x-axis, and it is open in the positive direction because the right side is positive. This is just a memory aid, so keep it like a memory aid. There is no logic behind it. The logic is slightly different. Okay, and the blue color parabola, that is x square is equal to y. Now I'll slightly magnify the required region. So this is the required region, and you can see that there are infinite number of points, and for my advantage I'm going to visualize that there are infinite number of points which are aligned parallel to the y-axis, So I'm assuming all the points are standing parallel to the y-axis. Now look at this. Even though these strips do not meet the x-axis, I want you to imagine the shadow of these strips. Okay, I'll make a strip anyway. So I'm making a strip parallel to the y-axis. If you want, you can do the same thing parallel to the x-axis. Okay. Now look at this. You can make the strip here, you can make the strip here, you can make the strip anywhere you like inside the region. Wherever you make, I want you to imagine a point on the x-axis. The projection of the strip, the shadow of the strip on the x-axis. So that clearly tells me the movement in the x direction is from 0 to 1. Look at this. These strips are aligned parallel to the y-axis from 0 to 1. And if you ask me what is the lower limit of the strip, it is very clear, the blue parabola. So I am going to write this: y varies from blue parabola to red parabola. I hope you understood that strip. You look at any strip parallel to the y-axis, it will vary from blue parabola to the red parabola. And the equation to blue parabola is over here. Y is equal to x square because I want the y value. So I am going to write y varies from x square to. Now the red parabola means y is equal to root x. So the upper limit will be root x. That's it. Limit evaluation is done. Now back to integration. So the given integral is over the region R. Now we converted the region R into limits, and it tells us x varies from 0 to 1. So remember, the outer limit will be constant and the inner limit will be y is equal to the variable limit. The inner limit will be always the variable limit, and the inner limit depends on y. So I am going to write y, and I am going to keep this x outside the integral, and I am going to write dy and dx. And for your advantage, I will make a. Okay, now what we will do is we will evaluate the inner integral first. Okay, so please keep this x here and evaluate the inner integral first. So we get x equal to 0 to 1, x is here, and y means y power 1, so we get y to the power 2 by 2 within the limits x square to root x dx. And now as usual you have to plug in upper limit minus lower limit. Anyway, I am going to do one thing. This 2 is an unnecessary thing inside the integral, so I am going to put it outside. So I will put 1 by 2 outside. Now what we do is like a regular integral, we put upper limit for y and lower limit for y, and there is an x here, you can keep that x here, and when I plug in the upper limit I get root x the whole square, and when I plug in the lower limit I get x square the whole square, that is x to the power 4. Now you distribute this x. Now this is just a single integral, a regular integral which you learned in your younger classes. So we get 1 by 2 integral x equal to 0 to 1. This x goes inside, so we get x square minus x power 5 dx, and that will be x to the power 3 by 3 minus x to the power 6 by 6 within 0 to 1. And now we can plug in x equal to 1 as the upper limit, minus you can plug in the lower limit, that will give us 0, and together we get the answer 1 by 12. Okay, now let's move on to another problem, a similar type, but this is very simple. Evaluate the double integral over R dy dx, and R is the region bounded by y square equal to x and y equal to x. Now look at this, y square equal to x we just discussed. It is a parabola symmetric about the x-axis, and since the right hand side is positive, it is clearly open in the positive x direction. And look at this, the degree of x and degree of y is 1, that means it is a line, and this is a line with constant term 0, there is no constant term. And if there is no constant term, then that line will pass through the origin. Not only line, let it be any curve without a constant term. Look at the parabola, it will touch the origin. Now I know that the slope of the line is 1, so clearly it is inclined at 45 degrees. So this is a line passing through the origin and inclined at 45 degrees. Anyway, first things first, and the first thing is find the point of intersection. So y square equal to x, and the second equation tells me y is equal to x. So I am going to get rid of that y. I am going to eliminate the variable. So instead of y, I will put x, and I end up with x square equal to x and x square minus x equal to 0, that is x into x minus 1 equal to 0, that is x equal to 0 or x equal to 1. And now what we do is, we have a parabola and we have a line, and we found that x equal to 0, we will find the corresponding y value. You can see that y is equal to x, so y is equal to 0, y equal to 1. That means the point of intersection is 0, 0 and 1, 1. Okay, and that tells me here I have to mark x equal to 1, and for my convenience I am going to take a vertical strip. So I am assuming all the points are aligned parallel to the, okay, I'll magnify as usual. We can assume all the points are aligned parallel to the y-axis. Now look at this, I told you, you can make the strip anywhere you like, but whenever you make the strip, you have to check the projection on the x-axis. It's obvious that x varies from 0 to 1. And it is obvious that y varies from, look at this, let it be any strip. If I make a strip here, the bottom point is the line, the above point is the parabola. So I am going to write line to parabola. Now equation of the line is y is equal to x. That means the y value is x here to parabola. Parabola means y square equal to x, that means y equal to root x. So that's it, we got the limits. Now time to integrate. I is equal to double integral. The first limit should be the constant limit, and the inner limit should be the variable limit. And since the inner limit belongs to y, I should put dy first and then dx. and for your advantage I'll mark this. Okay, now what is integral dy? Now plug in the upper limit root x. Root x means x to the power 1 by 2. Sorry for skipping steps, but it's something which you do in a regular basis. So minus x dx. Now that's it. This is the regular integral. So we get x to the power 3 by 2 by 3 by 2 minus x square by 2 within 0 to 1. Plug in the upper limit. So we get 2 by 3. This becomes 1 minus 1 by 2 minus 0 minus 0, and that gives me 1 by 6. Now I'll show you another question. And the question is like what you call, someone has already designed everything, and the question is simply evaluate the integral. Evaluate the integral. Clearly this area between two curves or maybe between x-axis, etc., etc. Okay, now this is very important. The reason is nothing is specified about the limits, and as beginners in multiple integrals, you may be confused which one belongs to y and which one belongs to x. It's very easy. You look at our multiple integral lessons 1, lesson 2, lesson 3, you will understand that the limits of y will always be in terms of x. And that gives me the confidence to write the inner limit belongs to y. And of course there are only two variables, so obviously the outer limit belongs to x. And the order is good because inner limit is y, means it will be dy and then dx. Now I'll rearrange this a little bit so that we get advantage in integration. I'm going to write this as 1 by x square plus y square dy and then dx. Now look at this. In class 12 you learn a lot of special formulae, and one formula looks like 1 by a square plus x square dx. If you do not know this formula, I'll strongly suggest note it. I'll put it in a box. Now look at this. X stands for variable and a stands for constant. We are going to integrate with respect to y, and that means x is a constant. When we evaluate the inner integral, x will be a constant. So I am going to get 1 by x tan inverse y by x within the limits y is equal to 0 to x dx. Now look at this. This limit belongs to y, so I am going to circle y. And just like a regular integral, x equal to 1 to 0, there is a small correction. Please make it 1 to 2. Please make it 1 to 2. Okay. And then what you do is you plug in x. So we get 1 by x tan inverse x by x. X by x is 1, tan inverse 1 is pi by 4. Minus, when you plug in the lower limit, we can see we get tan inverse 0, which is 0, the product will be 0. Okay, now this is equal to pi by 4, integral x is equal to 1 to 2, 1 by x dx. Now we know that integral 1 by x is log x to the base c within the limits 1 to 2. Now plug in upper limit and lower limit. So we get log 2 minus log 1. But log 1 is 0, so the answer will be pi by 4 log 2 to the base e. Now I will show you one more question that is very important. Evaluate the integral. So look at this. These integrals are given with limits but without any specification. Nothing is specified. We have to guess. And the method is very easy. You look at the inner integral. And from our past experience we can understand that if the inner integral is written in terms of x, then definitely the inner integral belongs to y. And of course that means this belongs to x. And that means the order should be dy dx. Okay, now I will keep the inner integral separately so that you can see that clearly. Okay, in class 12 you learned the formula 1 by a square plus x square, and the formula is nothing but 1 by a tan inverse x by a. But remember, in this formula x is a variable and a is a constant. Now look at this, we have to manipulate this a little bit. I am going to write x equal to 0 to 1, y is equal to 0 to root under 1 plus x square, 1 by root under 1 plus x square the whole square plus y square dy and dx. Now look at this, I'll tell you why. It sounds a little bit complicated, but it's very easy. Look at this. We are integrating with respect to y, and when we integrate with respect to y, x will be a constant, and 1 of course is a constant, so the whole thing 1 plus x square is a constant. So what I do is, I am writing 1 plus x square in the format something squared, and to make it something squared it is very easy, put a row, put square. Come on, think about it. If I want 3 to be a whole square, the simplest thing I can do is I can put root and I can put square. Now look at this, it looks exactly like the above formula, 1 by constant squared plus variable squared. So that's it. So we apply the formula, we get 1 by a tan inverse y by a within the limits y is equal to 0 to root under 1 plus x square dx. Okay, now as always, for your advantage, I will circle the variable so that you plug in the y values properly. So x equal to 0 to 1 by root under 1 plus x square. Now look at this, I am going to plug in the y value root under 1 plus x square, cancel, it becomes 1, tan inverse 1 becomes pi by 4. Minus, when I plug in 0 it becomes 0, tan inverse 0, 0, 0 into something is 0. I went a bit fast, but I am sure you understood. Multiplied by dx. Here comes another formula from your high school. 1 by root under 1 plus x square. Okay, I'll quote the formula here. Integral 1 by root under a square plus x square is nothing but x plus root under a square plus x square plus c. Now look at this, it's the same thing here, So we get pi by 4 x plus root under 1 plus x square within the limits x equal to 0 to 1, and that gives me pi by 4 1 plus you plug in 1, I didn't do our usual trick, you plug in x equal to 1 in the red color places, so you get 1 plus root 2 minus log 0 plus root 1, log 1 we get log 1 is 0, that's gone, so this is the answer. So you erase this. That's it. So I'll be back very soon with more problems. In the next few videos we will learn two very important things. One is changing into polar coordinates and another is changing the order of integration, because these things are asked regularly in the exam. So we will meet very soon. Till then, bye.